In the figure below, what is the potential difference between the point A and B and between B and C respectively in steady state? In steady state, none of the capacitors will allow any current to flow through them, and therefore there is no current flowing through this circuit. The resistors can be ignored in such a case. Now let's look at this part of the circuit. This point is shorted with this wire, so that joint can be moved onto this wire, and the same is the case on this side, and hence the circuit can be redrawn to look like this. Now, what are the potential differences between A and B and between B and C? As I said, there is no current flowing through the system, so the resistors can be ignored, which means this entire line on the left side has the same potential as point A, and this entire line on the right side has the same potential as C, and the potential difference between them is 100 volts as provided by the battery. So now, what is the potential difference between A and B and between B and C? On a capacitor, we have potential difference is equal to the charge stored on the capacitor divided by the value of the capacitance. Since both the capacitors, which is this entire thing acting as a single capacitor and this entire thing acting as single capacitors, since both of them are in series with each other, the amount of charge developed on both of them is the same, and therefore the potential difference across them will be inversely proportional to their capacitances, which is to say CAB by CBC is equal to VBC by VAB, and it is clear that the potential difference of AB, or rather it is clear that the capacitance on AB is thrice of the capacitance on BC. So we have 3 is equal to VBC by VAB. But we also know that VAB plus VBC is equal to 100 volts, and hence we have VBC is equal to 75 volts and VAB is equal to 25 volts. Hence a required answer is option C, where VAB is 25 volts and VBC is 75 volts.